All right, guys, so this is the first example tutorial for Design 2, Lecture 7 on reaction engineering. So I plan to go over the solution to the first example within the PowerPoint. So I'm going to switch it over to OneNote to make things a little bit easier. Hopefully you should be able to see. So this example it asks what factors favor the formation of R. Now, the way this reaction is set up, I have A plus B going to either R or a side reaction, which forms S and T. This reaction to R is reaction 1. The reaction to S and T is reaction 2. And our reaction expressions are, excuse me, are K1 naught E to the negative 8,000 over RT times, Ca times Cb to the 0.3 power. Reaction 2 is K2 naught E to the negative 4,000 over RT, Ca to the 0.5, and Cb to the 1.8. So, based on that information, what we're looking at is a comparison of the rate expressions. So, for example, looking at the activation energies of these two reactions, I have 8,000 versus 40,000, and the units are not given because we don't know what the R and T units are, and so we're just looking at this space comparison. So I see for the reaction 1, the activation energy is higher than the activation energy for reaction 2. This tells me that a higher temperature will selectively favor reaction 1. All right, now the second things that we can look at are the concentrations of Ca and Cb based off of the order of the reaction in relation, in relation to those concentrations. So looking at the concentration of Ca, we have Ca first order times Ca to the half order, which tells me that a high Ca concentration will favor formation of R in reaction 1. And looking at the second one, Cb, I see 0.3 order to 1.8. So to get high R favored, I want a low concentration of Cb. Oh, I never put this, of Ca. And there you have it. That is the solution I was looking for on this first example. All right, thank you guys.